Hello, everyone. Welcome to Philly on September 13th, 2021. Just a reminder to everyone, meeting is being recorded, and this is a CNCF meetup, so make sure to adhere to the CNCF Code of Conduct. If you have any issues, please let me or any of the other organizers know. Go ahead and share my screen. We'll talk a little bit about our talk for today, and then I'll run through a couple of the updates and things that I think would be pertinent since the last month since we've talked. So today we're going to learn about managing ConfigMaps and Secrets, which we all know is fun and is needed in a Kubernetes cluster. So hopefully we'll learn a little bit about how to encrypt them because we all know that they're not encrypted. I want to make sure that everyone's aware of the CNCF online program. They do a lot of meetups weekly, conversations just like this on a bunch of different topics. So that's out there. I'll make sure to post all of these links to the meetup as well. I've been to a couple, but not as many as I probably should be. And on a personal note, I would like to tell everyone that I'm excited to say that my book is being published finally. It is available on O'Reilly right now, and it is available on print October 5th. If you'd like to get a 30-day free trial of O'Reilly, send me a note, and I can send that to folks, and they can check it out. KubeCon's coming up. We were talking about that before the recording started. You can still buy tickets and go virtual. You get, I think it's a 20% discount. That discount code's been posted to the meetup, but if you don't see it and you want to attend virtually, again, hit me up in a DM on Meetup or in an email. I think I've posted that in several places. So if anyone wants to go, let me know. From a blog post perspective, there's been a lot of focus around security. And I know that just because I'm getting ready to do a DevSecOps, a container pipeline security webinar as well. So maybe it's that recurring theme just because I'm doing something, but how to detect runtime threats in Kubernetes. This was a pretty good talk. I know there is lots of talk around Falco with being part of the new ePBF Foundation. So that's something to look into as well. This one I haven't seen so much, and I need to read this as well because I didn't realize that the NSA and the CISA came out with a Kubernetes hardening guide, and now they have tests for it as well. So again, something to run tests up against instead of just using Kubebench and some of the CIS benchmarks. There's another thing to go around and look at on how to harden your Kubernetes updates. I've got it up here, so I'm definitely going to read it. Probably should have already read it since it's August, but it's something, another piece of information to get updates from. One of the other big ones that came out recently is the CNI spec has been updated to version 1.0. I think most of it was dropping a couple of deprecating some fields, but not too many new changes in the V1 specification. So check that out as well. Again, I'll make sure to post this to the meetup. And we've already got October. I've got October lined up. We'll talk about that a little bit at the end. And November is already lined up as well. If you're interested in speaking, again, the link is on the meetup site, or just let me know and we'll start. We try to do monthly. And if we don't have speakers, I can always just talk about anything. And with that, I'm going to go ahead and open it up to the floor. Does anybody have any projects that they are working on right now that they'd like to talk about? Is anyone hiring or is anyone looking for a job? So the floor is open to anybody who wants to have an announcement for the community.
Hey, James. David Roller. I work for a company called Investor Cash Management. It's small right now. It's a little bit past, I would say, the startup phase, but we're into the point where we need to start scaling out and growing. We're using Kubernetes and AWS exclusively, and we're hiring for a DevOps engineer / Kubernetes person. Level-wise, somebody mid-level. I think entry-level is probably a little too early at this point, but mid-level and above, we're definitely interested in talking to you. So you can either reach out to me, and maybe I'll post something in the Meetup chat after this. Thanks.
Definitely. Thanks for joining, and thanks for letting us know. See, I got a couple messages in chat. Oh, thanks everyone on the announcement there. And with that, I'll go ahead and should I just hand it over to you, Matthew, for the presentation?
Sure. See if I can figure this out. typically just share the screen and then present, or is it a...
Yeah. When you hit share screen, it's going to pop up and ask you what you want to share.
And I can present in that. So that works.
Yep, I can see it.
Sweet. Cool. Well, nice to meet everybody. I wish it could be in person. Maybe one day soon we'll be able to start doing that again. I'm Matt Conway. I'm the founding CTO at a company called Cloud Truth. We're basically trying to make managing configuration a little better in the cloud era than it has been historically. With me is Daryl Diosomito. He's one of the solutions engineers here at Cloud Truth. He's going to be doing some of the keyboard work, showing people various flavors of working with ConfigMaps once we get to that stage. So let me move on here. So let's define the challenges. Everybody knows that configuration is tricky, right? There are many ways to configure your application. If your application is large, that just compounds upon itself. On top of that, there are many ways to configure Kubernetes itself, and not just Kubernetes and getting it running, but getting it to run your application. So all the various components you might need to stick in there to enable your application, those take a lot of configuration as well. And that's what I usually call those non-application components that enable the application. So things along those lines would be, setting up your ingress controller or various operators and controllers in the system to make it easier for you to not just run your application, but manage it, monitor it, all those good things. I see there's some chat stuff here. Those just thanks. Okay, let's move on. So how does one manage configuration, right? It's tricky. So as we all do, right? You're starting off at 0 and you're just trying to get something up and running. So chances are you have a bunch of hard-coded strings in some application code. Bonus points if you've actually extracted out the constants, so you can, at least make it easy to find and replace when you move to something a little more robust. And then you typically progress from, all right, now I've got sort of my basic application working. How do I set this up to be, a little more configurable depending on where I want to run it or how I want to run it? So you tend to extract all those constants into some kind of a configuration file. It can be JSON, YAML, .properties, .env, XML, whatever makes you happy effectively. How do you kind of extract out the pieces of configuration for your application? I like to think of it as the configuration interface for my application. We're all software engineers at some level, and we understand the concept of an interface, right? So if you have a class, your class has an interface, and you kind of maintain that contract. But you're stepping up a level now. Instead of just a piece of code, you actually have a component in a system. It also has an interface. It has many interfaces, in fact, right? If it's a network-aware component, it'll have an API that's an interface to it. But it also has a configuration interface, right? What knobs and levers can I tweak to make my component behave a little bit differently, or even just make my component work at all, right? If it needs an API key for some external SaaS service, that needs to be known as part of my configuration interface, versus a setting that maybe increases the cache size, which you don't really need to touch that to get it to work, but it's still part of your interface for controlling that component. So then, moving up from just, basic files to configure things, sort of the next level is, not really the next level, but sort of a parallel level is using the system environment. So especially with containers, that has kind of become the de facto standard for allowing your image to not have to change depending on where it's being run. So you pass an environment variables to control it as its configuration signature, but you don't have to rebuild your image every time like you would if there was a file hard-coded into your image to configure the thing. So it lets you kind of decouple your your image from what's needed to get it to run in a particular environment. And usually when I'm saying environment here, I'm meaning things like, at least in a corporate environment tends to be things like development versus staging versus production. However, for people in the open source world, you want to build a single image and allow many people to use that image. So they shouldn't have to rebuild the image, for each user of that thing. They would just configure it with environment variables. So, when you're working with environment variables, a common pattern is to use something like a .env file. So .env, I'm not sure what languages it's available in. I think it's pretty pervasive throughout most stacks. But effectively, what a .env file lets you do is it lets you, define a list of all the environment variables that configure your component, right? So, it'll be your configuration interface for that component. And the nice thing is that those are just the defaults. So when you run your image and if you pass in an environment variable, it'll override what's in that .env file so that you can reuse that image in a bunch of different places. And then, the list goes on and on, right? It doesn't stop at 3, 4, 5, 6, 7, 8, 9, 10. There's many permutations and combinations of how do you get configuration data into your component. It could be an external system that you're calling, like a database engine or a SaaS service, or something else. It could be your CLI interface. When you start up the image, what command arguments do you pass it? That may be hard coded into your deployment YAML or pod YAML. There's many ways, right? But since we're in Kubernetes, we're going to talk a little more about ConfigMaps and secrets, because that's sort of that's what the Kubernetes body of knowledge pushes as the right way to decouple configuration from your application. So we'll dive into those a little bit and see why you want to use them. So if you go to the Kubernetes.io and you look up config maps, the very first thing they tell you, this is what a config map is and why you'd want to use it. It lets you decouple your configuration, like I've been talking about, from your image so that you can reuse that image in a bunch of different places. Now, my deciphering of that is, you want to keep your application code separate from your configuration so that you can get them to change independent of each other where you need to, but still keep them in lockstep if you need to for other reasons, right? But the whole idea is being able to reuse a single image depending on where it's being run. And that's what config maps and secrets enable. Now, anytime I say config map, you should inject into your mental stream config map and secret, because effectively they're the same except for a few minor differences. Secrets are effectively just config maps, right? They work basically the same as a config map when they're being consumed by your application. And the only difference is that you're kind of indicating to Kubernetes that this has data that needs to be secret. Now, they're not particularly secure. They're base 64 encoded, so it's really only protecting you from casual exposure, somebody walking behind you and looks over your shoulder while you're looking at a secret. They're not going to see it as often. They could still see it if you happen to be, inspecting that secret directly. But if you're just looking at a list view, they wouldn't see anything there. But it is expected that you would use RBAC controls to ensure that your secrets are only visible to the component that needs to see them. In terms of encryption, they're base 64. You can turn on encryption at rest. I'm not sure how useful that is, except for, as a checkbox on your security compliance, because, most of the time, I don't know about you, but my Kubernetes cluster is never at rest. So, if it's encrypted at rest, that's great, but, it's the secret's always available. So it's kind of hard to hide a secret from a thing that needs it without having another secret to control that. And then how do you control that secret? And it goes on and on. So it gets kind of messy. You're really only the only way to absolutely hide a secret from Kubernetes is if your application makes a network request to get the secret from a secret service of some sort, like a vault, for example, or something else that's holding on to your secrets for you. And that way, the secret's only ever exposed inside your thing that's using that secret, and it's not visible to the rest of your infrastructure. But it's convenience versus security. If you can live with the security guarantees that RBAC would give you, then it may make sense to have your secret in a secret resource instead. So I think I just was there. No, I missed that one. So how do you consume a config map, right? So a config map, it's basically a flat dictionary, and what I mean by that is you have keys and you have values, and the values have to be strings. You cannot have like a key reference another dictionary, which has a key which reference another dictionary, and so on down. It's strictly just a single level of keys and values. So if you're trying to port an existing application to Kubernetes, and that application needs some kind of structured configuration input, you cannot just use a config map directly like that. You have to do a little bit of massaging to get your configuration into a form that will work through a config map. I can go into that in a little bit once I go on to point number 3. Config maps are just Kubernetes resources like anything else, right? You can read them using the Kubernetes API. If you're writing an operator or something and that operator is configured through a config map, it can read that config map directly in versus having it be mounted onto the runtime. But for most people, if you've put data in a config map, you're gonna mount it to your pod to access that data, and that takes a couple of different forms. You can say, hey, this is my config map. It should go on my application, and I want every key and value in the config map to be environment variables on the runtime of the application. So that's the easiest way to use it, right? You have, some key, API key, and its value is XYZ. That will become the environment variable API key, which in your application could, ask the system, hey, give me that environment variable, and you'll get the value and use it that way. And that works naturally pretty well if you're already following sort of the .env methodology of defining your contract for configuration. It just makes it easy to get that variable overridden for the specific environment you're running in. The other way you can use config maps is as a volume mount. So what happens there is when you mount the config map as a volume, effectively every key becomes a file in the volume you've mounted, and its contents become the value of the key value pair in the config map. So if you mount your config map to /config, then the key foo has .yaml has a value of 5, then you'll have a file called foo.yaml with the contents of that file being 5. So that's the way if you needed a config file for your application that was structured in format, you would ensure that what you're putting in your config map is a key, which is the file name, and your value would just be a raw YAML or JSON or whatever you want in there, just a raw string without any structure to it. But once it's read in by your application, that's when the structure gets inferred across the contents. And then, another sort of, I don't know if it's a best practice or not, but, a lot of times you want to be able to change your configuration dynamically. So you want to be able to make a change and not have to redeploy or restart anything. So if you do your config maps as volume mounts, that'll happen automatically. As long as your application knows to check for new files, it can read the contents in dynamically without having to be restarted. If you're going through environments, you can't do that. If the config map changes, it'll never get seen until you restart the pod that's using that config map. And there's third-party tools that enable things to be restarted automatically when other things change. You could certainly set up one of those. So when your config map changes, it knows to restart the pod that depends on that config map. But another pattern you can follow is, linking your life cycles by naming with checksums. That's the way I think of it, right? So if your pod is depending on config map dash checksum XYZ, where that checksum is the checksum of the contents of the config map, then whenever the config map changes, then the checksum is going to change. And as a result, your deployment tooling will generate a new sort of YAML with a descriptor with a different reference in there, and thereby force the restart by doing a redeploy. That can be tricky to get working. Your deployment tooling has to be able to understand the dynamic nature of config maps and how you name things. So, depending, some tools may have it built in, some may not. But if you want to be able to use environment variables and trigger restarts without third-party software running, then that would be your best option on that front. So that's kind of the quick overview of config maps. And then I'm going to hand it off to Daryl, and he can kind of show you how you would use those in practice. Assuming I can, there we go. Stop share and.
Thanks, Matt.
I'm not sure how to give the screen to you. Oh, you got it.
Yeah, I got it. All right, thanks everybody. And what we're going to do now is we're going to go hands-on. And I'm not sure where everybody's Kubernetes journey is at this point. So we'll start kind of from a lower level from config maps themselves, and then we're going to move our way up to a dynamically updated config map secret system with the operator that Matt was kind of speaking of. And we would like this to be as interactive as possible. As part of the notes to this meeting, we are developing kind of a new tool to help out with this, and always looking for direction and your use cases so we can continue to build this out and make it as valuable to the community as possible. And I apologize for the no video. I'm dealing with some low bandwidth struggles today. So the very first use case we're going to get into is how you manage and apply config maps directly from a config map itself. So I have a very basic config map from the Kubernetes IO site. It has a set of file-like properties and keys. And one way to apply these config maps is with the kubectl command. So when we apply this config map itself, I'm running on a Minikube cluster. Immediately gets created. I don't know if anybody's ever seen this K9s tool, but it's a pretty cool way to view and manage your Kubernetes clusters. This is a view of my default namespace within my Minikube cluster. And you can see that I've got my properties and key files directly created from my config map on the apply. Now that config map itself is living locally on my machine, so there's no real repository or any way to check values or files. So it really is kind of just a demonstration of how you'd get a config map in a Kubernetes cluster. I also have a Minikube dashboard. So I don't know, what does the community typically use? Are we CLI based? Are we using a Kubernetes dashboard for some of these managements? What do you guys in the community use in general?
Kubectl, or if I'm on Google, I like the Google UI is pretty nice, just for viewing things and getting around.
Yeah, that Anthos
Yeah, but as soon as you hop
layout?
over to like Azure, it's just all raw YAML. So
Right.
Yeah, I usually try to stick to just using Helm
Okay.
for deployments.
All right. And where is everybody kind of on this call, just to get a sense? Is everybody running Kubernetes clusters now, or are we serious operators, or just kind of looking to get into the Kubernetes space?
We're running it in production.
yeah, I've
Awesome.
been doing Kubernetes for a couple of years, and it's my daily life.
I don't want to be mean and
All
steal
right.
the thunder. I'm the Ingress Nginx maintainer, or one of them.
Awesome. All right, so that was boring then, and we'll continue to move on. Since you guys are pretty much power users, what about Customize? Have you started using Customize to deploy these config maps? Is anybody using that?
Like I said, we usually use Helm, or we're trying out Pulumi so far, which actually seems to be pretty nice too.
I'm hearing lots of good
Yeah,
things
that-
about Pulumi.
Yeah, we run it now, and it actually replaces a lot of Helm with its own thing, but then it ends up just using raw, config map style commands, like kubectl commands on the back end. So it's got some
Right, and-
hiccups though. So sometimes you do have to fall back, especially if you're running something big like a GitLab Helm chart. Then it starts to fall apart because there's so much to that Helm chart that it starts to get a little bogged down.
What
Okay.
in particular about Helm are you trying to fix with Pulumi? Out of curiosity.
I guess it's not so much fix. It's that instead of having Helm and Terraform and some other thing, everything's wrapped up in Pulumi. So all of the infrastructure is built there, and then the Kubernetes deployments happen from there too. So we deploy the servers from it, and then it will, when the servers come up, it'll then run all the spin up all the Kubernetes components, like all the Nginx ingress and all that stuff, just gets spin up as Pulumi code, and it's all in TypeScript. Or Python. You can do either one. So you're basically just writing TypeScript. So if I want to throw a function in there in the middle of it to do something fancy, you just write it. That's like the big positive. The downside is, like I said, on more of the fringe things, you start to kind of like wish you had Terraform because there's just more support right now for it.
Right. It's more the one ring to rule them all methodology, right? It all works easier because you have one system to interact with.
Yeah, including secrets. They dump secrets and stuff in there too, which is really nice. They have their own way of encrypting the secrets and then storing it up there, or you can do a local server.
Right.
Like, that's an option for us. We're going to end up probably doing Vault because we need the extra Air Force compliance, but
okay,
like it's not bad. I will say, at first I was kind of, nervous about it, but after using it for probably 8 or 9 months now, I don't mind it anymore. It's not bad as a daily driver.
cool, thanks.
Yeah. What language are you writing your Pulumi in?
Right now it's all TypeScript because that's where I was most comfortable. As a team, everyone was most comfortable with TypeScript. And most of the examples are written first in TypeScript. Like I said, you can use like Python and stuff, but there's less examples and stuff to go on when you do that. And it just seems cleaner, right? I mean, you're writing everything in TypeScript, and then when you have to do like a YAML block or something, it's very similar. So it's pretty easy to translate it.
All right. And what about configuration management and overlays of different environments? So, for example, if you were writing an application, and one method we see out there is having a GitHub repository with multiple branches that house different configuration data for each environment. So right here, I have a GitHub repo with development, production, and staging.
Mm-hmm.
And in there, I have my properties files that I can create config maps from.
Sure. It's the same thing. You would have a YAML file for each environment, or you can do it dynamically. So we have one for production staging, like all the big ones. Those are like their own YAML files. You can either dump in raw YAML in there, or you can do pull that into like an actual config file. So you can do TypeScript on top of it before it pulls in the configs. But the other thing that we're doing with it is you can also build that config out dynamically. So every time someone pushes a code to our demo branch, it creates that environment, like a one-time use kind of thing. And then once it's done, it nukes that environment file and then cleans it up. So we only have 3 persistent environments, and the rest are on the fly, generated from this kind of like almost like a example defaults config file. But that's
okay. And do you have any pain points in that area with trying to track what your configuration values are across environments? Or is that working pretty smoothly for you?
It seems to work pretty well. A lot of stuff is tucked into feature flags and tied into GitLab pretty heavily. So without GitLab there to kind of track what's deployed where, it could probably get a little messy. But that's kind of falling more in the GitLab side of things anyway, in terms of like, okay, what environment did I deploy this branch in this version to? You know what I mean? I don't know that you'd necessarily be like, hey, did I deploy that with, what version of Pulumi or whatever, for example. Usually you would look more in like GitLab deployments and be like, okay, it deployed Saturday with this, hash or whatever.
Yeah. Right. So I'll just kind of continue on with this example, right? If we create a config map from this GitHub repo with which branch I'm in the development branch. It creates values directly out of that GitHub branch. If we went and switched to a different branch, we can easily change the values for that configuration. Just from, if we were to check out a production branch rather than the development branch I was on, and then update that config map. Now, is that a pattern that people see being used out there outside of, as part of a CI/CD pipeline as well, to pull in values from different branches within a GitHub repo? Or has anybody else used that pattern or seen that done within their Kubernetes environments? Or are people's environments smaller where they're not really that worried about, a dev, a prod, and all those values that are distinct between those?
Currently, all values are stored in, at least for me anyway, in GitLab variables that are not secrets. And then GitLab will, depending on the branch and the environment, deploy XYZ set of config values, if that makes sense. So you don't need to save your values ever inside your repository itself, like as a file, which is not quite as good practice. You kind of want to take it out of, being in the source repo itself. It's just easier that way, in my opinion.
Right.
Do you currently use config maps, or is that just something that's been too much of a overhead to deal with?
Who are you asking, myself or?
Yeah. Or in general, just anybody. I mean, do people in general use config maps, or do they tend to just do everything through some other mechanism?
Well, the other mechanism ends up putting it as a config map, at least in my case.
Right. Okay.
So the think of the config map and the secret as like the end result of what you want.
Right.
And then these other tools that we're talking about are just ways to end up with that in the system.
Makes sense.
Just because that's kind of how Kubernetes wants to ingest it. It wants to ingest a config map or a secret. It doesn't want to like go into your source code and try to find some file that you have stashed somewhere. That's not really a good way for it to do it. So these are more just mechanisms to deploy that config map.
Right. Yeah,
in an easy way.
Yeah, that's sort of the native method for configuring things, is you put the data in a config map and then use that config map with your thing.
Right.
So that question is, I guess you could do everything through environment variables directly in your descriptor, but that's not a particularly scalable way to do it.
No, it's not. Yeah, and I mean, later on, you kind of also want to eventually be able to move over to like feature flags and things like that,
right?
Where your code will actually look for certain flags, so you can kind of turn off and on features on the fly as opposed to rolling new code every time,
right?
And then that just becomes even more, variables that you got to put in as opposed to the hard coded things.
Well, yeah, because I was just thinking in my head for some reason, I was like, well, you could just put that in the config map, but to read the feature flags from the config map, but you don't have anything watching it for a reload or anything.
Yeah. We're using the GitLab feature flags stuff right now, and it works okay, but we're trying to move over to something more robust because anytime GitLab has a problem that risks the stuff that's actively running, like if it reaches out to see like what flags it's supposed to have, and it can't come back with something, it has to use defaults, which is not as good. So I think they have a couple solutions out there, but
I mean, if you do feature flags through a config map, at least you're a little insulated from upstream failures, right?
Yeah, I mean, that's kind of like part of the best practice, right? You're supposed to have sane defaults that if I can't pull this thing, go back to the config map and grab XYZ. You know what I mean?
Right.
Like, so it's not broken if it can't get, that option.
As long as you can, if you're using sort of file-based config maps like mounting as a volume, those will update periodically on the file system in your running container, right? So as long as your tolerance for updates is like, a minute's okay, and you have a way to scan for that file being changed, you could do feature flags that way. It's just not as quick as, something like Launch Darkly, right?
Yeah, Launch Darkly is actually what we're looking at right now. So
a lot of people are looking
to be the winner. Yeah.
Well, one thing that one tool that we're kind of building, and one use case that we've been kind of looking at for Kubernetes is, this generation of config maps and secrets from a centralized configuration hub. And that's kind of what CloudTruth has. We've got a parameter store and a secret store that is basically Vault as a service. Our secret store is backed by Vault. Each organization gets their dedicated Vault that secret's encrypted end to end with a JWT. But what we can do is with this data is we have a set of environments, in this case, development production stage. We can build environments that are children off of any level. And our parameters then exist as a default across that top level environment and trickle all the way through. And then once we have that data, we have the ability to compare values across all those environments. So kind of like that GitHub branching strategy, but kind of, in our opinion, a little bit of an easier way to see what the differences are with those values. So with using your GitLab variables, do you find it difficult to kind of diff those values across different environments? Is that a problem that you or anybody is facing today?
Yes. Actually, we hold 4 to 5 non-prod environments, and then a production environment. And it's very difficult to, for each release, we have multiple environments in place, and we move over for every release to a different environment. So the configuration, the config map, which was already there previously, if it has any new changes, it's kind of difficult to track down in all the environments. Yes, we are actually facing this issue.
Right.
So
Okay,
part of that
yeah,
would be
and so-
infrastructure as code, though, right? I mean, if somebody changes your config variables, you should know by having to have a merge request or something put in there, right?
That's correct. Yes. Yeah, we follow the GitLab repo for the source code thing. Yeah, we do have that practice, but sometimes during the new environment readiness to be delivered, that's when the first time we face this kind of issues, all the config issues, all the URLs, endpoint URLs, they might have got changed, but it's not updated in the GitLab, or maybe on the fly they updated the cluster. You know what I mean?
So they did live edits on the cluster without putting in a proper merge request to get those values
That's correct.
changed?
Yes.
Mm.
Man, you really trust them to make edits on the cluster, huh? That's pretty bold.
For a dev cluster, I would be okay with that. For a production cluster, that's a different story.
Right.
Yeah, right. But does this with our environments and our overlays and parameters, we also have what we think of as transforming the data. So creating config maps with these dynamic parameters can be done with our templating engine, and then you could select whichever environment, and that environment will get different values depending on the perimeter values that you have in that environment. Then you can leverage that with our CLI or API and kind of like build config maps off it directly with a very simple, well, I say very simple, but with a little bit more visibility into what your values are across all these different projects and environments. So for instance, I have this project config map. I have that set of parameters inside of it that set up an application. I have a different project flash map that sets up a different flash map application. I can compare the values between all the different environments. Here, I just have a simple dev prod staging, show the differences, have my config maps inside a template, and deploy config maps in that fashion. We can also put that all in CI/CD pipelines, and it's kind of helping us understand what all our values are across all these environments.
Yeah, effectively.
So I'm not. Go ahead, Matt.
I was just saying, back to that configuration interface, right? Being able to have a way to quickly understand what I can change for my component, make the change, and have that change go, to a specific environment is pretty helpful. As with anything, right? If you have 2 or 3 components, it doesn't really matter what you do, right? It doesn't really matter how you get that system up and running because you don't have the scale. But once you start adding more scale, not just in terms of performance, but number of people working on the code base and deploying it, and a number of people using it, a number of teams and repositories, it starts to become really difficult to keep on top of all the changes that are happening in your system and have that sort of top-down view as to what does my system look like right now, or things are broken right now, what did they look like yesterday? Things are working in staging but not in production, why not? Answering questions like that it helps to have that top-down view, which is what we're trying to do at Cloud Truth, right? Not just for Kubernetes, but whatever the tool you're using, give you a way to take your configuration interface and share that data between different components, and give you that the ability to ensure that configuration changes reach all those hidden nooks and crannies in your system that need it whenever they change. So it's one aspect of that is what we're doing with Kubernetes, right? Where allowing you to define a whole bunch of projects and set the configuration interface for them, and then automatically generate the config maps for those projects and secrets, to ensure that your applications are always have the right configuration in the right environment and so on. And everybody does it a different way, which is part of the challenge. You want to be able to give people a way to do what's natural to them. So we're trying to at least give them a way that's Kubernetes native by allowing you to set up a config map and a secret for each of your components, and then be able to manage that at a higher level. Anyway,
so how does that compare to Rancher, for example, has a nice top-down view as well of all your clusters and the config maps for each deployment. I guess, what are the compare and contrast, I guess, between the two?
I haven't used the Rancher.
They're showing you I think they're showing the deployed config maps. They're not actually hosting the repositories where those config maps are getting deployed, are they?
Not necessarily, but it's more of like a UI interface in terms of you can see what's changed, and you can give RBAC control to individual people to change those things. So I guess it's more of a top-down view in that sense of what's running right now. Let me see, this deployment, who changed what when with this config. I'm just curious because there are definitely some similarities, but I was trying to figure out exactly what.
I haven't used Rancher, so I don't know off the top of my head, but I'll definitely take a look and see if is Rancher actually provisioning data, or is it just observing data? Do you know?
You can edit and stuff like that. It gives a nice, pretty front end for it. So if you have a not so savvy Kubernetes user, and you just need them to be able to edit a couple config map settings, they can hop in, click the little edit button, type in the field, I need whatever, save, and it'll do an on the fly deployment update of that for them.
Okay, gotcha.
This is more of a source engine too, where we could take all of our parameters and secrets that are stored in the vault, as well as our third party. We integrate with third parties such as AWS Secrets Manager and GitHub themselves, where you can pull values dynamically into these parameters, and then let you do something like run and apply directly from a config map in Cloud Truth, and it can go out and just create that config map for you. And then you have an auditing system of what those values are. So not necessarily editing post, it is more validation up front.
Okay. And then is there, what's the, do you guys have any kind of plans for any kind of government space, or only commercial right now?
Not sure what you mean.
Only,
just because if you're dealing with secrets and stuff, I'm just curious.
Oh, in terms of our security compliance?
Yeah.
Yeah, so we're working on SOC 2 right now. That takes a while. So, but other than that, we all of our secret data is we can't access your secrets. They're all protected with JWT that's issued by a third party, Auth0. And since we can't log in as you, we can't get that JWT to decrypt your secret store. So your secrets are protected from us, but we have to prove that, right? And the way one proves that is by documenting it with something like SOC 2, which we're working on right now.
Okay. Yeah, I'm mostly asking because, like I said, we have Pulumi secrets right now, but it's not FedRAMP compliant.
Yeah.
And Vault is, but Vault's a beast.
Yeah.
So I don't really want to have to stand up Vault if I don't have to. But that compliance seems to be a big hiccup because it's a pain to obtain.
Yes, it is. So your secrets are effectively we're hosting Vault for you, right? And the Vault encryption keys are done through that JWT token mechanism I mentioned. So, it's always tricky getting exceptions to your compliance, right? So even though it's FedRAMP and or whatever other standard you have to go through, right? There's sort of the golden path, and then you can always have exceptions, right? As long as you can justify them. And if that exception is we're using some SaaS service and they're SOC 2 compliant, that's a pretty easy exception. If you're saying, we're sticking all our secrets in a text file that's on Matt's laptop, that's a little harder to get through. So, yeah, our goal is to be, fully compliant there and make it easy for people that need that compliance to be able to not have to worry about exceptions with us. But this stuff takes time, and we're still pretty new. So,
well, Matt, if anybody wants to try out a demo in their clusters or anything, how do they get access to something like that?
Yeah, just go to cloudtruth.com. There's a free trial button. Just go ahead and sign up. Log out, Daryl, and show them the button.
Right. Well, I'll show you guys two more quick things, right? So, like I said, you can apply these config maps directly, spin up your app. As you can see, I pulled that from the production site, but I can also directly pull it from staging. And this is mounted as an environment file, not a volume. So when we apply it, we can re-roll out our pods and quickly and easily get, configuration changes that way. So if we were to do a rollout, it's going to pick up that new config map image. Refresh here, I should get the new image, I get the new environment. So it's just one way to kind of break away from the GitHub diffs and trying to figure out what all your values are and easily compare across environments. And then I'll show you guys the KubeTruth piece, which is an operator, which will dynamically pull projects and secrets directly from CloudTruth, whether they're integrated through AWS Secrets Manager or SSM Param Store, and then create all your config maps and secrets for you.
So our operator, basically, it's trying to do is, if you have a convention for the way you organize things, all right, say you've got 100 different services and, you want config maps for each of those. We make it very easy for you to define the, say you use .env files, right? You can, at CI time, push that .env file to CloudTruth, which sets up the configuration interface for the project named after your repo. And that'll give it all the default values. And then what the operator will do is we'll say, for every project, create me a config map with the same name. So it lets you leverage the common patterns across your naming and code base and, and configuration so that, managing 100 services is just as easy as managing one service. And, in terms of what the operator can do, right, it's basically just doing server-side applies. So if you give it the, permissions, you can even make it do deploys, right? You can make it deploy or create templates for each of your projects or create a common one and share it across all your projects so that, you can always deploy your services in the same way. And then even go as far as to, do that sort of checksum linking of ConfigMaps to to their content, so that whenever a config map changes and its checksum changes, it automatically restarts your pod, right? So if you wanted to follow that pattern, it wouldn't be very difficult at all. But yeah, it's all about leveraging common patterns whenever you need to scale up. Trying to make that a little bit easier for configuration, and specifically here for Kubernetes configuration. Anyway, sorry, Darryl, I didn't mean to steal your soapbox there for a minute.
No, it's all right here. I'm was just trying to clean up my previous demo. And yeah, like you said, what does everybody think about the ability for an operator to dynamically create config maps and secrets on the fly? We've seen that resonate with a few of our users, and we're trying to understand if that's something that is something we should keep pushing on as a use case.
I think definitely, yeah. This is like the other person said, hundreds of services, maintaining config maps. It's kind of difficult in multiple environments. Yeah, this is kind of a breather for all of us.
So the use case would be that if I needed to change like my auth token to my third-party API, it would do the reload for my applications for me with only having to change it in CloudTruth.
Yeah, you could.
Yeah, it
wouldn't be difficult.
Yeah, that's correct.
I think that would be hugely helpful for organizations who have to manage. One microservice can probably talk to 10 or 20 upstream services. So being able to do that across the board would be really helpful.
Yeah.
I guess the one thing is you have to be pretty careful though too, right? If somebody typos something, you're rolling that typo. So your health checks and stuff have to be pretty tight before you let them just roll.
Yeah, we definitely
have. Darryl, I think that I was going to show you here. We've added a little bit of validation, so you can set up rules for different parameters, and our templates themselves maintain referential integrity. So you can't use a variable that doesn't exist. But here he's showing you rules. So you can say this parameter has to be an integer, and it has to be between 5 and 10, or there needs to be a string with a regex match. And then in the templates themselves, you can do things like, all right, somebody, can typo a variable that doesn't exist and end up with nothing, right? But with a template,
that makes it a lot easier. How do I know what image it's pulling? Is it just going to pull latest, or it's going to pull the existing and then just reuse existing image?
It's however you define it, right? So we don't have anything hard and fast right now. We just have a mechanism in place. So, however you define your templates, if you want your template to reference a parameter that's the image version, you can do that. And you can make that equal to latest, or you can make that a specific version. So when CI runs, you basically, you would set the parameter to be whatever you just built that image to be. And then that'll trigger the whole workflow. And
so what if I need to roll back though? How would I do that?
Change the image back to the older version, right?
Well, let's say I'm on latest. I roll because I changed an integer, but something else broke. Somebody pushed some code and it wasn't, it rolled it correctly. How would I get back?
So if you're always on latest, and never on a released version, then I don't think you have a way to roll back regardless of what system you're using, right?
You would have to roll forward then.
Yeah.
Yeah. Well, I mean, like if you were using, I was going to say, because if you're using like Helm still keeps its own version tracking, right? Even though it's latest, it's still not really latest.
Even
like
with the deployment, right? When you're doing deployments, you can do a rollout or revision. So when you deploy, after you deploy in the rollout, there's a rollout history. So what I do is when I do a rollout, I add the image tag number as part of the deployment to the rollout history. So then when I look at the history, I know which previous one, which revision, and it will have a revision number and the tag as a description in the description. So I can say, okay, go back to this revision number.
Yeah. No, that is
rollout history is enabled by default now, isn't it?
Yeah, it is enabled by default, yes.
Okay.
But you can add whatever description you need to it, right? So in the script, the tag number is a variable and the service is a variable. So I add that as part of the description. And then when I do a rollout history, it shows me everything. And then I say, okay, you can actually go back to not only the back, you can look to third revision or fourth revision, whatever revision you want to go.
Yeah, same with the Helm too.
Yeah,
but
exactly.
I guess we are discussing about the config map. If it needs to be, if it needs to be rolled out.
Config map is difficult. Yeah, you just have to go to GitLab and go and get the previous one usually. Yeah.
If your config map is named after its checksum and your deployment YAML, references the name with the checksum, then if the config map changes, you'll do a new rollout with the new reference to the new config map. And the old one's not going away, so you can always roll back to the previous one as well, right? But
config maps don't change that much, right? I mean, usually config maps.
In this case, we're talking about when we do change it and somebody foo-bars it.
Yeah.
How do we fix that? Yeah.
But the nice thing about
that's a good use case.
Yeah,
everybody has like a,
which is some of the challenge of being a DevOps company. Is trying to satisfy all those. But I guess we could always preach best practice too and say if you do it this way, you won't have any worries.
One thing we do have is a history, so you can kind of take a look at your project, see what your current values are, get a history from a specific date, show the differences across those values, see what was deleted as well.
One of the other things too, I think, and this might be helpful for you all, is an enterprise feature allowing changes or just like approvals. Like if somebody's changing a password,
right?
I don't know if you'd want Cloud Truth to be the one. If Cloud Truth is managing passwords and rolling out updates based off of those changes, I would probably want another person's set of eyes on it. So kind of like how like in GitLab or GitHub, there's some kind of flow. So some kind of enterprise RBAC on changing passwords or changing specific config maps. That might be helpful, I would think, from an enterprise perspective.
Like a code owners for config map.
Yeah.
Yeah. So, some of the, features coming in the near future are, finer granularity for RBAC, being able to, kind of do workspaces for grouping changes together, right? And then an approval process for, somebody making a bunch of changes, kind of like a pull request, effectively, like with GitHub, but just around configuration. But, got to start somewhere, right? So this is where we are right now.
I definitely see benefits, and I see this being useful.
We are adding, we do have tagging. So, if you don't want to sort of always get latest, you can reference, give me my configuration state for tag staging or release 5 or things like that. So that, only the person that updates that tag in the production system is actually the one that's going to get the changes pushed out. So that's another way of doing it.
Yeah, it would be super cool though if there was like literally right next to code owner, there was a config owner file, and you could just do that. And you guys could parse that because then you could keep it in code who has access.
No, yeah, definitely. That's a good idea. I have to mention that to the team.
Dale, you want to continue with the dynamic demo?
Yeah, I'm trying to pull it up now. Unfortunately, my Minikube cluster kind of shot itself. Now, I don't know how quick you would be able to pull it up. I'm seeing if I can revive my Minikube cluster right now.
See here. No, I don't have it in a good state. I just tried doing Minikube and it was Something's wrong with mine. I have to reset it before I can get it up. But if you're curious, can we have a video of that somewhere for Cube Truth?
Yeah, we do. We're making another one right now, too.
Well, you got 2 out of 3 demos, so that you're doing pretty good. The demo gods were just so nice to you.
Yeah, this is our operator. So any code we write that we expect our customers to run, we always release as open source. Our CLI is fully open source, and our operator for Kubernetes is open source, and they're just using our API back to our system. So it's our web UI uses the same API these tools use. So we're just trying to give people the same access that we have ourselves to eat our own dog food, I guess is kind of the right term there.
Gotcha. Okay.
How robust is the templating in there? Is that a normal Go template or Spring or something that Helm I think is?
We started off keeping it minimal. So right now the templating language is Mustache. I'm not sure if you're familiar with Mustache. Yep. But it's a logicless template, and it just basically allows you to reference variables. I think you can do loops and things too, but we don't have any variables that have collections. So maybe we'll add that at some point. We were thinking of adding more capable template engines so that you could pick and choose what made sense for you. But for now, it's Mustache only. Okay.
And I'm trying to just, maybe I missed it. How do these relate to the secrets on the back end, in Vault? I know that's usually path-based, right? Or a pseudo path. It's basically all the path is the secret, right?
So when you create a parameter in Cloud Truth, you can choose to indicate that parameter is a secret. And if you indicated that it's a secret, then we store it in a hosted vault for you.
Okay, you take care of all of it. Gotcha.
Yeah, we take care of it all for you. So all you care about is this a secret or not, and we handle the secret side. And then on the operator side, by default, we set it up so that secrets end up in Kubernetes secret resources and parameters end up in Kubernetes ConfigMaps. But you can change all that if you really wanted them all in the same place. You could do that too.
Okay. And in terms of segregating permissions and things like that, is that possible at this point? An admin will have access to all the secrets, but maybe I have a development environment where only the developers are able to change their secret.
Right. So our RBAC right now is pretty minimal. We have owners, contributors, and viewers, but we don't have a way to restrict by environment, but we're making a push to update RBAC to be more granular. So we'll allow things like project-based, environment-based restrictions on who can access what. Or secret-based, right? So you can do everything in the project except see the secrets, for example.
Gotcha.
We're just not there yet.
Yeah, the secrets templating is huge. I mean, I've been at a few places now where templating those out with your own kind of thrown together homegrown thing can be a pain.
Yeah, and like we said, if you don't want to store your secrets in Vault, hosted by us, we are integrating. These secrets right here are coming from SSM Secret Manager. This is AWS Secrets Manager. And the way that works is you edit the value, you set up an AWS integration or a GitHub integration. And in this case, this is my AWS Secrets Manager. And you could just put that value directly into a key with Cloud Truth.
Yeah, that's great.
So we're kind of letting you, we're letting you take things from GitHub, we're letting you take things from wherever your existing infrastructure is, but letting you get the power of that environment overlay and the visual of seeing what your values are across all those environments, being able to compare, see the history.
Yeah, we're decoupling. People always make fun of me, in the company for saying this because I like the word decouple, obviously. But we're decoupling our configuration interface from where the values come from, right? So you've defined, hey, my component needs these variables set. Here's a list of a half dozen variables that need set for this one component. Where you get the values from for which environments, it doesn't really care as long as you give it a value. And Cloud Truth helps you manage where those values come from. So it could be S3, it could be your Terraform state file in S3. So, for example, you've provisioned some kind of resource in Terraform and you want to share that provisioned identifier with your application. It makes that kind of workflow really easy. If you want your secrets in Secrets Manager or Parameter Store, you can do that and then just share those through to, when you kind of connect the dots, so to speak. That's the idea anyway. Yeah, check it out. All feedback welcome. You can click that try free button. It'll give you a free trial for, what is it set for, 14 days now? But
I think it's 30 now.
30 now? I don't think anything changes when your trial runs out. So, use it as long as you find it useful. And if you wanted to, use it in a production setting, then obviously it's always better to pay for things used in production, right?
But yeah, I am scrambling to get this Kubernetes dynamic update demo going, and if anybody would like to see that, and we don't do it in the time allowed, we'd love to get together and give you that demo one-on-one.
By all means, you can reach out to post my email address in this chat here in case anybody wants to contact me. Should be obvious from the website too.
All right, and if you find that video, definitely go ahead and post that to the meetup. Daryl, we'll put you out of your misery and let you off the hook, because I know how difficult those always can be. Well, does anybody have any other questions for Matt and team? All right. Well, I thank everyone for coming today. And like I said at the beginning, October 26th, we've got our next meetup. So Kubernetes Policy Management with Kai Werner. I think I pronounced that correctly, but I'm sure we'll find out if I did on October 26th. So thank you, Matt and Daryl and Katie, for helping manage and put this all together for us.
Thanks for having us.
Thank you, everyone.
Thank you.
Have a good evening. Bye.